Hello everyone, in this video we will be seeing what is overfitting in model evaluation. As we all know that previously we have discussed some problems will arise due to the data when we are evaluating the performance of the model, right? One such problem is overfitting. So in this video we will be looking what is overfitting versus underfitting versus overfitting, and what is the impact of overfitting on performance, approaches to reduce overfitting. So we have different terminology here, right? What is a signal? It refers to true underlying pattern of the data that helps the machine learning model to learn from the data. Noise, it is a familiar term, right? What is noise actually? Noise is the unnecessary and irrelevant data that reduces the performance of the model. Bias, oh my god, this is a very complex term. I don't know. So what is bias here? Bias is actually the error we get. That is, bias is a prediction error that is introduced in the model due to oversimplifying the machine learning algorithms. Or in a simple word, it can be said that it is the difference between predicted values and the actual values, or how far the model is from the ground truth. What is variance? If a machine learning model performs well with the training set but does not perform well with test data set, then variance occurs. Now we have seen the terminology, right? Now we'll move on to what is overfitting. So in simple terms, what is overfitting? Usually, apart from all the definitions given here, we can simply say that suppose you have a data set and you have trained the data set on a model and you have got 99.999 accuracy, so which is so very good, right? But this is when you trained your model on the training data. Now when you test your model on testing data, your model gives some accuracy like 50% or 60%, which means your model is well trained but it can't perform well on new data sets. Means your model was learned the parameters right fit, like it just learned everything from the training model very neatly, so it can't predict new values correctly. This is the problem of overfitting. Means training error is so less but testing error is very high. So there is more error in testing data than training data. This is what overfitting in simple terms. See, it is said that ML, machine learning models, can actually generalize and produce high complex explanations of relationships between predicted values and response variable, where fit may be excellent. But however, when we used with unseen new data, the models of great complexity may not do so well. Overfitting happens when a model learns the details and also noise in the training data to the extent that it negatively impacts the performance of the model on new data. Which means, as I said earlier, it is excellent performance on training but poor generalization on new data. So overfitting produces poor predictive performance, which is testing performance. Past a certain point, the error rate on the new dataset starts to increase. Conversely, underfitting occurs when the model fails to capture or generalize the underlying pattern in the data, mostly due to oversimplicity of the model. We have underfitting, right? So what is underfitting? We have learned about overfitting. Now what is underfitting? See, in overfitting, our model learns the trains on training data very well and gives the high accuracy, right? But in underfitting, the model fails at the training data stage itself. It can't even find the underlying patterns in the data, or the data set is too less so that it can't build some relationships between the data points. So that training data itself, the model fails. So this is underfitting. See, here we will have given an example, underfitting to overfitting in regression case. Here we are having three graphs, right? So here initially we have a linear model which is giving accuracy of 89.5%. Here the model is very simple. The simple model, it is underfitting actually. When we come to a quadratic model, it is just right, I think. Accuracy is 93%. But when we come to polynomial model, see here the data points, the training model trained on exact curve, exact. So it is what? Overfitting. See, accuracy 99.99%. See, we can see another example here. It is underfitting, which means high bias. As we told you, actual minus predicted values is so less. Just fit. We use the quadratic model here. And overfitting, which means high fitting was just right so that it can't perform well on new values if given. Here we can see a graph representing overfitting and underfitting. See, error. Initially, for both underfitting and overfitting, error will be high. But when we are training the model, if the model is having underfitting, initially during the iterations, model complexity will be decreasing and accuracy will be so less. But what is overfitting? Initially it will be error is high, but then in the end we have high accuracy, very high accuracy. What are approaches? Now how to reduce overfitting? Because our ultimate aim is for our model is to perform well on unseen data or test data, right? So here there are three main approaches for it to reduce overfitting. That is partitioning the available data into training, validation and test partitions and performing cross-validation. These things we'll see in the next video. Reducing the number of features used in building the model. It's so important to take the features which are necessary and reduce the unnecessary features in the data which we used in data science techniques and regularization model. So what have we seen here? Overfitting, which means excellent performance on training data but poor generalization or performance on new data, also known as high variance. What is underfitting? Underfitting is poor performance on training data as well as poor performance on testing data, also known as high bias. So complex models with zero error typically end up overfitting. Partitioning, what's the solution? Partitioning of data into train, validation and test, partitions for cross-validation, reducing number of features, regularization, etc. are some of the techniques to reduce the impact of overfitting. This is it. Thank you.